Hello everyone, my name is Benjamin Knight and this is Project Apt, sponsored by Elbit Systems of America. My team members are Michael Bonnet, Michaela Hay, Jose Ibarra, Jorge Estrada, and Kartiki Sharma. So what is Project Apt? It's essentially a drone carrying a payload that is capable of hacking. Our sponsor was looking for a proof of concept that combines offensive security and drone technology. It is important to note that we are using this strictly in a white hat hacking scenario, which means that the attacks done are to prove flaws in the security of a system and not actually affect its confidentiality, integrity, or availability. You might be wondering, what is penetration testing? This is usually done by security companies hired to test another company's defenses. This includes their physical, network, and social defenses. It can also include their recovery plans, such as what happens after an attack. So what might this project be solving? In a typical attack, the very first line of defense is restricting access. This can mean fences, cameras, or even security guards blocking access to a site. The offensive personnel have to go to the site themselves and risk looking suspicious, getting caught doing something they're not supposed to, or leaving tracks. Drones can solve this by flying over walls, being out of a camera's line of sight, and reaching areas that would otherwise be impossible for someone to do. More importantly, if a drone is caught or fails, the person operating it is far away from and cannot be traced back to themselves. Drones are also extremely fast and cover a very wide area quickly, scanning for networks and looking for cameras and entrances. So how exactly are we implementing it? From a high level view, we have a drone that is carrying a payload capable of performing attacks. Both the drone and the payload are controlled through a 916 MHz radio, while attacks are carried out over Wi-Fi, separating the two communication channels. We're completely creating our own target system, which is a Wi-Fi network and a vulnerable computer due to the legal issues of hacking. Here's a data flow diagram of all the components in our system. If you are more interested in these details, go ahead and pause the video. This is an abstracted parts list. This is not exhaustive of all the parts used in the entire system, but are the main components used in each subsystem. I think it's important to note that there are a lot of Raspberry Pis in this list. We decided to go this route because of the amount of documentation available, low cost, and ease of configuration. The vulnerable system itself consists of a router projecting an open Wi-Fi network. Wi-Fi cracking was not one of the requirements from our sponsor, and we were specified to not spend time trying to implement it. The target computer has the Ubuntu Mate operating system running VSFTPD 2.3.4, which contains a backdoor vulnerability. This allows us to get a remote shell and complete control over the system once the exploit has been ran. Here's a finite state diagram of what the actual system is supposed to do. First, our drone will lift off, and then it will continually scan for open Wi-Fi networks. Once one is found, it will connect to the network and begin scanning devices on it. For each device found, it will perform a vulnerability scan, which detects if it is a particular operating system or has some sort of open port that can be exploited. When a vulnerability is found, it will perform the exploit and gain access to the system. From here, there's a myriad of things that can be done, but we have chosen to upload a file to the desktop of the computer, proving we have gained access to it. So here's sort of a basic demonstration. This first clip that we're about to see shows off the software that is running on the drone. In our case, this information on the left is what we really care about, as it shows the live data of the drone. Here's a little bit more of it flying. We're going to go ahead and skip ahead here. This is a circuit diagram of our payload. The LED is used to indicate the status of it, and the module to the bottom right is an Adafruit RFM9X. That gives us radio communication to the payload. In this next clip, we can see how it works. On the left side is the base station sending commands over the radio, and the right side is the payload itself. When a command is ran, the LED is going to turn green, and whenever it's idle, it's just going to be blue. In this clip, it's what is happening on the desktop of our target computer. You can see that a text file gets generated once the exploit is ran. If we have a lot of ideas for the future, if another senior design team wants to adopt our project, or if one of us chooses to take it up for a master's thesis. Just wanted to take a moment to thank our sponsor. Because of them and others, students like us can actually work with amazing technology like this. Otherwise, we may never even be exposed to it. Thank you.